right. The graph below displays the relative frequency distribution for X, the total number of dogs and cats owned per household for the households in a large suburban area. For instance, 14% of the household own 2 of these pets. So 14% own 2, 9% own 3, et cetera, et cetera. According to a local law, each household in this area is prohibited from owning more than 3 of these pets. If a household in this area is selected at random, what's the probability the selected household will be in violation of the law? Well, more than 3 means this group right here. They're the bad ones. So if I add these values up, I'm going to come up with that likelihood. And that's all I had to say. Is all I really had to show were those sums and that total, because I'm looking for 4, 5, 6, and 7. So 0.07, 0.04, 0.04, and 0.02, which sums up to 17%. So that was a pretty easy single point. If 10 households in this area are selected at random, what's the probability exactly 2 of them will be in violation? Well, because it's exactly 2, it's a singular value. Now we have I should back up, say we have a fixed number of trials. Fixed number of trials makes this a binomial. And we have a probability that we calculated ahead at 17%. So that's our formula. And this is a binomial PDF because it's only a singular value. So binom PDF, trials 10, probability 0.17, X equals 2. But the reason I had this problem is for this next part, because it is given students fits on lots of things recently, including project test. The mean and standard deviation of X are 1.65 and 1.85 respectively. So they're telling me that this is my mean and this is my standard deviation. Suppose 150 households in this area are to be selected at random, and X bar, the mean number of dogs and cats per household, is to be computed. Describe the sampling distribution of X bar, including its shape, center, and spread. Well, the mean is easy. The mean is the mean is the mean. So X bar is 1.65. We don't have to do anything with that. Also, standard deviation is pretty simple. We're talking about standard deviation of X bar. Regardless of the sample size, it follows this formula. So the standard deviation is going to be 1.851 divided by the square root of 150. And even if it had been a small sample size of 3, that would still be the standard deviation of X bar. X bar always has this formula. I don't care what the sample size is. That formula is true regardless of the sample size. The problem is the shape. So the shape, we have to have a sample size of 30 or larger. In this case, our sample size is 150. So which is greater than 30, which means the sample means is approximately normal by central limit theorem. And we like that phrase there, sample means, or the distribution of the sample means is approximately normal by central limit theorem. All right, real quickly, if we've been working with proportions and we wanted to know what the shape is, and initially we were working with this, because this is a binomial, all right, but our sample size is large, so it becomes normal by central limit theorem. If I wanted to know about proportions, P hat will equal P. The mean is the mean is the mean. But what we're going to run into a problem is the standard deviation, which, and not the standard deviation, the normality. And NP must be greater than 10, and N times 1 minus P has to be greater than or equal to 10 if we're working with proportions. All right, so that's our normality condition that we have to worry about there. Okay, oh, and I guess I should answer the question because it's about to come up. P times 1 minus P over N would be the standard deviation for proportions. That's the standard deviation of proportions for the sampling distribution. All right.